It's me again talking about tuning. What's on the plate for today? I need to close this because it's making me crazy. And I hope you still can see me even if I am not watching myself. So, stream started rough again. I had to restart the computer. Then my audio interfaces decided it won't boot up and got stuck in bootloader mode. That's why I'm late again. And of course, pissed off of my of my gear. I need to get some proper gear for streaming. If anybody has tips, has good experience with some gear, let me know in the chat. I will research it until the next stream and will get a proper interface because the GoPro picture is okay, but it's frequently decides to die on me and I have to restart it. Hey Noctaro, hope you're good. So, we talking ESCs today. Brenton, show me the log. Show me the log. We'll take a look on at it, of course. So here is the program. Of course, starting with the wrong. Okay. To get a bit of a grasp on the ESC settings and what can and will go wrong if you change some of the things. I'll do a brief explanation of what an ESC is doing. Then we go into the different firmwares available because they differ quite a bit in their mode of operation or in the details how the settings are implemented. Then what everybody needs to know these things because like 90% of time when I change something in the ESCs, it's because I got these things. I tend to have them at the end of flips and rolls where the motor is pushed against the wind and revs go really low. It got better with dynamic idle, but it's still there. Then we'll look at out of the ordinary build. Like ordinary build for me means like 3 to 6 inch. Everything bigger has to be treated differently, and whoops are you run setting on whoops that wouldn't make sense on anything else. So that's out of the ordinary. Last but not least is tuning for performance. I personally don't do this unless there's a specific need to get like you can't get more than like 15% of of torque by the settings by mostly by running lower timing. Um, and you have to decide for yourself if it is worth the hassle to toy around with those. So we'll get started with ESC operations. Motor basic accommodations, zero crossing thing. Let's start with the motor basic. You get my talking head again. Oh, it's ugly. It's ugly as shit. I need to restart my GoPro. No, now it looks better. Nah. If I move too fast, it's not happy. Okay. I'll leave the program here while I restart the GoPro and hope it will work again after another restart. Meep. No. Yep. Uh, motor basics. What kind of? I need to get the biggest motor I have. So it makes sense. Okay. This is an 18. No, you can't see this. I just got out a 5008 guard with an 18-inch prop. So let's turn the GoPro on again and see. if it's any happier than before. So our motors work with spools and permanent magnets. So the basic idea is you got a spool and a permanent magnet, and if the in our case the permanent magnets are outside on the bell. Let's see if my freaking head. No, it's still. It doesn't make sense like this. Okay, any settings I can change from the GoPro itself. Okay. Let's put it to narrow. Yeah, that's me. Okay. Yeah, looks better. I'll have a cigarette. You'll watch this piece of hardware. It's an 18-inch drivetrain. I'm currently building a frame around it. So we have the stator. Those wonderful spools. Now I'm moving the stator. Normally the stator is screwed to your frame and only the bell with the magnets move. So how do we make the magnets move? If one magnet is close to a spool, let's say we want to move in this direction, and this magnet over here, we turn on this magnet slightly before the magnet passes, and we turn it off when it passed. So on a standard 5-inch, we'll do this. We got 14 magnets, 14 poles on a magnet, divided by 2 is 7 by 3. We do this 14 times for every rotation. And these 14 times, no, 12 times, are it's always pairs of spools that get powered. It's always opposite pairs of spools get the power at the same time to get their magnet closer. That's why we got ERPM. So we power those spools and hope the motor starts turning in the right direction. At one point, we just need to know the motor is, when we're starting up blind, powering first spool, second, third, until we are done a full rotation. That's why ERPM is way higher. It's the pairs of magnets that need to be powered to get one full rotation. Hey, Glorious Crowd. Hey, Chris. Okay, nice cam. Let's see if it will make me look sexy too, but I'm married, so it's not a necessity. And at a certain point, when the motor is pulled up, the commutation. The commutation is the act of powering up one spool for the sake of getting this next magnet closer. And how do we know when to do it? There are sensor motors that have an optical sensor down here that they know exactly when the motor is in which position. We don't have this, we all use sensorless motors, so we have just the wires to power the spools. What we need to power a phase is 2 wires. They power a phase, and on the off phase we can measure the zero crossing, because the turning motors, the magnets, will always induce a current when they pass the spool. And once the once the zero crossing happens, the ESC after powering his spool, he's listening on this phase if there is still current, if there is still voltage generated from the spinning motor. At one point, you have a zero crossing where the spools will still give a current even if the magnet has long since passed, because it takes some time for the spools, for the magnetic field to subside. So this is the demark event is when the spools don't actively give a put voltage to a phase. And the zero crossing is the point between one phase, between the phase being powered, getting a building magnetic field, then the power turns off and the magnetic field subsides. And at one point it's exactly at zero, and then the next spool will come past it and induct a new field in the other direction, which will give opposite voltage. And this is the zero crossing. And from the zero crossing, the ESC knows we have passed between two magnets, and then it's time for powering the next magnet. So when we measure zero crossing, yeah, funky. Wait, it helped to just change the. Okay, it's fine. When we have a zero crossing, we know it's time for the commutation of the next phase. And we treat one electric phase, one pair of magnets is treated as 360 degrees. So 360 degrees is not a full motor rotation. 360 degrees, speaking from the ESC, is a fourth of a rotation on a normal motor. Hi, Brian. So as long as the ESC properly can measure the zero crossing, it can power the next phase, and it knows almost certainly that it's in the right position to power the phase. The timing in degrees is how much later we start powering the phase. We need a bit of a margin. We could run power through the spools from 0 to 180 degree, and from 180 to 360 is the off time. With three phases, no, it's 120, sorry, 120 degree. But we need a bit of margin that gives the ESC time to detect a zero crossing. If a zero crossing gets missed, most ESC softwares will just keep powering up the next phase and hope the next zero crossing will be detected. It internally has a metric how often it misses the zero crossing, and if this gets too high, it just cuts power. Depending on ESC type, original B Heli S would, after 5 or 6 missed zero crossings, would just cut power to the motor. The other softwares nowadays do this much more gracefully. It holds a matrix and it powers down. It just applies less power than commanded until it got the zero crossings proper, and then it ramps it up. So, you know what a zero crossing is? You know what a desync event is when, depending on settings, when your AC is not able to get a zero crossing for 2 to 3 full rotations of the motor. Hi, Electronics. Yeah, we need fast comparators to get the zero crossings right. Um, these things. Okay. The firmwares we talk about today. It's not all of them available. I'm not sure if FATEC has. I have a FATEC rig somewhere. If FATEC has all the same settings, I think it should have the basic settings like all the other softwares. Uh, but it has some special features that you probably won't use ever for a good reason. So on the 8-bit side, we have originally just BLHES, which kind of died when we reached a point where RPM filters are essential to the flight characteristics with Betaflight 4.2, I would say. It wasn't. It was strongly recommended not to run without bidirectional D-shot. There is JAC, and there was another commercial clone from or a fork from BLLES that had bidirectional D-shot as well. But nowadays, just put BlueJ on. It's like the most complete software you can run on the small BB8 chips. On the 16-bit side, we have like I think 90% of the ESCs run BL-Heli32. A strong contender because it's open source software and it's free. If you buy a BL-Heli32 ESC, someone paid Stefan. I think Stephen Skauk made BL-Heli32 and he's licensing it out. So EM32 does everything BL-Heli32 does, but a little bit better and for free. But you can't flash it over the D-shot wires. If you have a BL-Heli32 ESC, you can flash it via the pogo pins on the ESC, but you need to have a good eye to solder to those, and you can't go back. I still encourage it if there is a known target for it. You can always do it, but you won't win that much. And there is FATEC. Yeah, it's closed source, no idea. I have some I have an AIO and I have one ESC from them. They work, they do the same stuff as everybody else. The only thing which would be nice for big rigs is they got sign mode commutation, which I just found out BL-Heli32 has as well. Yeah, good point, Nerdcopter. EM32 doesn't do at the moment, I think, more than D-Shot 1200. I just looked over some logs from Alka. Wait, I want to show you this. Because it has absolutely no sense in running anything higher than 1200. You won't win anything by it. You just probably generate more D-shot errors. And I know the Kiss gang loves it. A bigger number is better. But the motors to spool up, if you have the motors at a constant velocity, you get my head again if it's working. Almost. And it's showing me what's happened long before. Okay. Let's change the camera set. Yeah, it automatically gets nervous when I click on the other screen. Weird. Okay, when I have my mouse over here. Oh, not right now. Yeah, ramp up speed. Or what can be done and how long does it take? Anyone has an idea how long does it take for a 5-inch motor with a prop to spool up from 2000 to 10,000? That's not big numbers. It's about uh 40 milliseconds. 40. When we go from T-shot 1200 to T-shot 2400, we're talking about potential nanoseconds to be gained from it. It's just not worth it, because you give the ESC with D-term, you give it more erratic signals, because D-term is always really fast, and the ESCs have no time to react on this. You're just making your ESCs go crazy. So, I need to. No, I want ESC configurator for this. We'll put it wrong. Yeah, when I do something on the right screen, that one over here, it starts pixelating. As soon as I pull it on the other screen, everything is fine. So I'll make my head a little bit smaller. Here is your friend for your 8 bits and your AM32 ESCs. I will not use the development fork. Mm. And yeah, let's try this one. No. I need a USB cable. Let's see if it works. So, kids, don't do this at home. I don't have. I can't find my smoke stopper. Usually, when I work on ESCs, I even got the props off. When I work on ESCs and settings, I use a smoke stopper up to 3.5 inch. I have to confess, I leave the props on. I'm just too lazy. I just have my left hand on the rig in the center. Let's connect. If it will, no, it won't. Port was used by another app. Okay. I want this one and connect. Come on. It doesn't like my GoPro being connected. Let's try another port. Oh, it's a hot tip. Okay, reload. Reload. No, it won't. Oh, have you seen this? Get the right port. This is an Airbot Phoenix AIO, which comes with AM32. So put this on the side, read the settings. I'll do one for BlueJay as well. So, it's a bit behind, but it's working. So, never change a running system. Okay. Chris, since you're here, Can I change the language on the fly? Because it's German. It's obviously reading my system language, and no one wants German parameters, and I don't want to mistranslate. If Chris is still here, yeah, he is. Guide me. Oh, over here. Sorry, I'm blind. Missing the obvious. So it's English. Okay. So what do we have here? We just do a quick run over ESC protocol. We all use T-shot. We could nail it to T-shot, but we don't have to. It's so fast on to init the T-shot. Timing at once. First and foremost, this is how much earlier. No, later. Chris, timing at once is later. As far as I'm aware. Okay. No one knows better. But I think the with cars, the ignition timing is going to the negative if it's an advance, and it's going to the positive if it's a delay. Chris, please enlighten me. Because Style Sucks is in the chat, he did it. Wrong at once. Yeah, but I say it's a pity we don't have Alka or Daniel here. They certainly know better than we all do, because higher timing would mean we're powering the spools earlier. To give them more time for zero crossing detection. So this is in degree. The range is quite limited. It's it allows for zero. Come on, okay. So if you pull this all the way down to zero, if we want the maximum torque, so we can use the whole active phase to power the spools, but it eats up on the time slot available to detect the zero crossing. So usually with 16 degrees you're good. If you have these things, you reduce you higher. Make something higher. My English lags quite a bit. You increase the timing to gain more time. Startup power, let's see how I could use. This is for spool up, when you at almost zero revs, how much power the ESC used to try to get it started. This is incredibly important on whoops, because they need a lot of current to get through the first 5 revs, and it's really hard to detect. The slower the motor is spinning, the less voltage it is, the less EMF it's putting back to the phase. Yeah, start success. I think you're still at the timing. So startup power is usually enough if your motors have a problem when arming, getting revving first, or if you fly against the wind. So in a stall situation in Bratwurst, the wind is actively breaking your props, breaking in the sense of making them slower, slowing down your props. But with dynamic idle, we usually don't get in the range of startup. So it's basically when you arm and the motors don't spin immediately or start twitching around, you need more startup power. So it's mostly needed on whoops, which never ever come with an AM32 ASC. but I'll show you the setting for how hot. Oh, okay. I have an O3 here, so let's be quick. Motor KV is and poles is used by only by AM32, which allows it to adapt the ramp up power to the speed that is expected from the motor. So the ESC knows the voltage and it knows how fast this motor can spin. So it gets an idea at which range it needs to apply lower power to allow it to gracefully spin up. Complementary PWM is always on. We need to power down the props fast, to rev them down fast as we rev them up. So without this, your motor would be essentially freewheeling when you get off the throttle, and it would take forever to spin down, and your pit loop will just spool up because it can't brake fast enough. Variable PWM. It's a topic all of itself. If it works, fine. If it doesn't work, take static PWM. We gain a little at higher RPM with going higher with the PWM rate. So what we're doing is, since we have FETs that we can only turn on and off. So to apply 50% power, we turn them on, off, on, off, on, off, on, off, and say it's half of the time on, half of the time off, so we have 50% power. And we do this at a rate of the PWM frequency, which is 16,000 to 128,000 times per second, depending on the ESC. Why lower PWM frequency gives you more torque, especially down low, is every time we switch on, we switch off, we insert that time, because the FETs take some time. Lost my phone. Take some time to turn off, and we don't want to turn the next FET on before we have this FET off. If this happens, and both FETs, the high and low side, the high side FET is connecting to the battery plus, and the low side FET is connecting to ground, basically the black battery wire. And if both FETs are turned on at the same time, we have shoot through. So the voltage, the current is shooting through both FETs and back to the battery. And it's like guaranteed that we will burn our FETs and probably suck the battery down when this happens. So we have to insert on every switching cycle, we insert that time. It's a matter of nanoseconds. But if we, while the phase is active, if we're switching 500 times, this adds up. So lower PWM will always give us more torque, especially down low. A higher PWM will give more precise control of the duty cycle, but only if the processor is up to it. So what variable frequency PWM frequency does is at low RPM it uses 24 kilohertz and it ramps up the PWM frequency with the speed of the motor. So in some cases you can get electrical interference from the back EMF, which is a divisor of the PWM frequency, and if this hits, let's say, exactly at the gyro frequency, it can make the gyro go crazy. I haven't seen a rig where 24K is interfering with the O3. There are some advices to use a higher PWM frequency if you get cello. I didn't have a single build that had this issue, so I can't judge, because we're talking about 24 to 96,000 cycles per second versus 50, 60, 100 hertz, which is the sensor's readout from the O3. I would be hard pressed to find. Usually it's just a tuning issue where you got some resonance or system resonance at exactly 30 or 60 hertz, which would hit the image refresh rate of the O3, if it's that sensitive to it. And there is better ways to tune it on the Betaflight side than giving up torque. So variable PWM will have the high PWM frequency dictated by the motor revs, and the low frequency when you get off throttle will always stay at the lower end. So if you're off throttle, you will always have perfect braking. If you're on throttle, you might gain a little bit of efficiencies, especially for whoops. But then again, on whoops, you just have 8-bit ESCs, unless you're crazy and build something like an airport into a whoop. What's next? Running brake as much as you can get. You want braking power as much as you want acceleration power. Sinusoidal startup. This is just for startup, especially on big motors. You won't power the phase with the full throttle value. You will on startup you will have lower duty cycle. In the center you have the full duty cycle, and then ramp down the duty cycle again. It gives a smoother start up of the motors, which helps. But there we talk about 10-inch plus, where this really makes sense. It sounds really nice. FATEC is doing this, and the startup sounds like ramping up some sci-fi movie contraption more than it's not starting, it's more, but it doesn't make a difference, honestly. Safety settings, dark motor protection, leave this on. When you're when the initial ramp up of the motor don't work, which usually means either your motor is damaged or you got something stuck in the props, it will just stop after 10 attempts and will force you to rearm. Stall protection. I don't know if we really need this. I will ask Alka about it, because I'm not sure which RPM range those systems are are active. Because with RPM filtering and dynamic idle, if you use dynamic idle, Betaflight itself will make sure your props don't stall. A stall is when the props come to a standstill, so I need to rev up from 0, which might be a problem mid-air because it takes some time. Yeah, it will give you more torque down low if you turn this off, but you shouldn't be in a region where this is even active. So if you set your min RPM to something fitting your prop size, then you shouldn't run into this. So low voltage cutoff. Yeah, I'd rather fly home with a dead battery or kill the battery in the process than have the ESC turn off, because the ESCs won't turn off all at the same time. Because if they have voltage sensors, if each ESC has a voltage sensor, they won't be calibrated to the million volts the same, and this difference would just make one corner cutting power than the other corner cutting power. So I'd rather kill a battery than not going home. It's more for cars, yeah. If you, but for cars now there's an Iridium Master put out an Express LRS controller for cars, so you can get voltage telemetry. And that's a good point. So I'm 90% talking about multi-rotors and not cars. Temperature limit. It's a double-sided sword, I would say. Be aware that this is the temperature of the MCU, and the MCU gets way later hot than the FETs get, and the region they work in, they should be able to work in, are similar. So the FET is back to like 120 degrees Celsius, and the MCU is back to 100, 110 degrees Celsius, depending on. There are MCUs that are pretty sensitive to overheating, but they won't build any more SC with those. I think there are 3 or 4 models with this MCU that got the temperature problem where the back AMF detection doesn't work because the CPU is over temp, and this is happening already at 80 degrees. Current limit, fine if you have a current sensor for every ESC, otherwise it won't help. And servo settings we won't need. Now let me get a whoop. I could have powered this off all the time. Just now plugging off the AM32. Let's have a quick look what a whoop ESC does. I'll take the analog build. It's less prone to overheating than the HD0 build. It's a micro USB. Here you go. Cable out. Nice thing, we can stay within. Yeah, props on for the win. And reload. If you watch a recording of this later on, I'll just leave it unedited with all my flaws. in it. Make sure to watch the live chat replay. There are a couple of people smarter than me in the live chat, so it's worth having a look. So, oh come on. I'm too hasty. Where did it go? Let's try it once more. Serious day. Oh, it is on the right port. Okay. Power. And connect. Read settings. Here we go. And turn off power. I hope the VTX doesn't run on the 5-volt rail, but you never know with Happy Model. So with BlueJay, the PWM frequency is fixed. You select it when flashing. I found for whoops that 48K gives still enough torque, especially when braking, and efficiency gain going from 48 to 96 is measurable, but not worth it. You really get a more floaty wig because it's braking way less. So we have motor timing in coarser steps than you would see on a 30-bit ESC, but it's plenty enough. Same here, if you run into these things, especially at the end of fast flips, choose a higher timing first. If your props won't spin up, raise those two together till the reliably spin up on every arming, even with a low battery. If you still have like 3.6 volts in your cell, it should spin up without any problems. If not, raise those a bit. A lot of people just put both of those sliders to maximum value, but it shouldn't be needed. You might look out for a different motor if you need both on maximum or a better ESC with less dead time. Motor timing talked. Demarc compensation. Look, it's me hovering over the question mark. Yeah, it is. How many missed zero crossings are you willing to accept before you power down to get a reliable zero crossing again? And usually it is good enough on low. If you have a shitty ESC, this is two parts playing two things playing part here. One is how good is the voltage detection on the ESC, and how much big back EMF does your motor produce. Usually a flatter, bigger motor will give you less back EMF. It's harder to detect. A smaller starter with a tighter air gap gives easier to detect back EMF. If you think your ESC is desyncing too early. Lower this. But I think it's the default setting. Oh, you can turn it off as well. But I would highly recommend against this, against turning it off. RPM power protection is I don't know where they how fast the motor spin. Okay. Because we in on the ESC settings we have a lot of conflicting information. People call the same mechanism by different names, and even worse, they use the same name for different mechanisms. So if we trust on Daniel's initial naming of the setting and description, it's limiting power when you're ramping up. So you have you're sitting, your prop, your motor is spinning at a constant RPM, and then you increase throttle, and for example, you increase from 25 to 75%. So the ESC could put 75 percent duty cycle on it and let it spool up, but it doesn't do this. It just allows an increment of a multiple of an increment of how much it can change within one from one T-shot signal to the next, I think. How much more power it can apply to the phase, which means it will ramp up slower, but once it reaches the target RPM, it stays consistent. What I've heard Alka talking is that it only allows a change of a certain increment from one commutation to the next. So we're talking about, let's say we are at 10,000 RPM, or 60,000 is easier. This is like 1,000 revolutions per second. So this can change 3 times in one full motor resolution. So this is the amount you're allowed to spool up. When I wouldn't touch this without seeing a log with eRPM. Honestly, the symptoms would be if you apply too much power, then you get a missed zero crossing. You're potentially applying the power too late, so at the end of the phase you already start to pull the magnet back instead of pulling it forward in the direction you want. So slowly, if you want to tune it, slowly raise it and see if you get these things at snap moves. At the end of a snap move, you have the lowest RPM possible at the prop, and the PID controller will put in the highest torque request possible at such a move. And there it's most dangerous to apply too much power to not revving up but stalling your own prop, and as a reason For this reason, you would get desync events or demark events until it just desyncs. Beeper strings. Is a yeah, I think it uses for melodies. Ramp this up. If you're like me and too lazy to put a beeper on your rigs, ramp this up. It's better to burn a motor than not find your rig. Don't put it at 355. Okay, it's a 8-bit value, but put it to 200. Beeper strength is when you actively put on the beeper. So the beeper strength is when you use the D-shot command to make the motors beep, and the beacon strength is when you disarm. So you're at 0 throttle for 10 minutes. You can set the delay time over here. This helps if you haven't set a beeper for RX loss. It will still start beeping after 10 minutes without you interfering, and it will be louder than the normal motor beeps. Brandon, yes. This Blue Jay RPM power protection is always active. This only helps in accelerating, and it limits how fast you will be able to accelerate. Whatever throttle you will send to the ESC will get reduced to what you allow per step to ramp up. Once your motor is at full throttle, it doesn't matter anymore. It will apply. It will leave the accommodation cycle at 100% duty cycle, and the motor will just draw as much current as it needs. So when you fly with throttle on into opposing air, it will just load the motor more, and it will stay on the power you command via D-shot. Only when you're at lower RPMs, when you have to change RPMs a lot, then it will limit how fast it can accelerate. Because accelerating too fast will cause late demarc events and misses of zero crossings. So you basically ramp this up till your rig falls out of the air. But there is more to be gained here than there is on the timing. So I'd rather go with a higher timing and more power, more ramp up power, than with lower timing and less ramp up power, more ramp up protection. Oh, damn it! I said those wrong. That's why this rig won't power up. Yeah, Blue Jay made a special settings for 1S powered rigs. So on whoops, you should always set this to 1S on 1S whoops, of course. It will help a lot with spool up and ramp up power. Okay, someone. No, don't. Wanted to send the log. Yeah, when to how to see desync in a log. It's quite clear. It's just um, you will have 100% motor output at the motor, and it will not change its rotation accordingly. That means D-Shot is asking for power, and the ESC says no, nah, can't, can't give any more. Yeah, I also had this. Brandon, I just read your comment on the log. No. Brent from America is calling. I will call him back another time. Changing AC load and yeah, there will be cases. I had two of those in all the black box logs, black box tunes I did, where the dynamic notch doesn't get a resonance peak. I don't know why. One case it was on the edge of the range from the dynamic notch. And it just ignored it. It was inside the range, but it just didn't get it. So what finally did the trick is lowering the range on the other end, on the high side of the notch. I changed it like from 70 to 570 till 500, and I reduced it from 70 to 380, and then it locked on the notch, on the resonance. So let's watch a log if you're willing to open it. Let's think if there are any BL Haley 32 settings that are still relevant and not covered in what we got so far. Right. Do I get that? Ah, fucky. BL 32. Ramp up power, temp protection, low RPM, power protection, sign mode, yeah. Who wants it? Maximum acceleration is at maximum. Oh, okay. This gives percent per millisecond. This is how much are you allowed to change the duty cycle per millisecond. So it's a more concrete number if it really represents this. So you need to give the motor some time to spool up, and this is the range is up to 25 per millisecond. So this is the maximum acceleration would milli, it's 8. Basically on 8 D-shot commands you would only allow every 25% spool up. and it takes the motor that long. So it's actually not worth going any faster. Let's leave this on auto. Motor timing. Um, yeah, a BL Haley has automatic motor timing, which means if it detects too many demarc events where it can't detect a zero crossing, it will pull power to get in sync with the motor again, and it will raise the motor timing. So if you put this on auto, but you will end up with 4 motors with 4 different timings. So I I don't think that will help a lot. Throttle calibration beacon. Yeah, we talked about variable PWM, everything else. Yeah, try sign modulation. It sounds nice when it spools up. Let's see. That's one. Let's just. Give me my traces back. Otherwise, yeah, it's my computer being funny again. So here we go. What's in this log? This is the one with the 250, which won't get caught by the notch. Pull it out of my face. Two 51K, 2K. Hello. I light my cigarette. It will immediately pop into life. But that's not the one with the 250 spike. Let's see if it's on page. Oh, come on. Do I need to threaten you with the task manager? Sometimes Windows starts behaving as soon as you start the task manager to find out what's misbehaving. Yeah, I got 31% CPU and sorted by CPU, everything is zero. Yeah, it's OBS, okay. Okay. Now that's brightness is the same rig. Yeah, having too many dynamic notches. If you have more dynamic notches than resonant peaks, the notch that is left over erratically jumps around. and it offsets your gyro traces by the delay of that one notch that jumps around, because they usually move pretty slow. So we have, yeah, this is that resonance. One request to all of you: if you uh, fly with taking a log and having that in the back of your head, spend 20 seconds on doing your tuning moves. Throttle ramp, throttle pumps, snap moves on roll, snap moves on pitch, jaw around a bit to see if it stays smooth while jawing, and fly into prop wash once. That's all I would like to see in every log I get, because this is a log that ends at 42% throttle, maybe more, maybe 45% throttle. So we don't know what happens. We can interpolate it that the motor bands will just go on like this, and the third harmonic will stay here. But we can't see. We can guess that this resonance is pretty strong when the motor band hits it, but we don't know if it stays active at high throttle. This comes into play when you move up your D term, which is way too low. Because where's the clean gyro signal? Because you don't need to filter D term for the motor harmonics anymore if the notches work. You just check once in the filter traces if there's any trace of the RPM harmonics. If yes, you might have set the poles wrong, but Discord. Oh, MW. Let me check his log first. Sweet. RPM telemetry. Open that up for me. And I will, Brent and I will check your other log later. While the other one loads, let's see if I got any step moves in here. Yeah. No, you got a little overshoot, but nothing bad. I would run a bit more P-term on the rig. Not that much. But you still have some leeway if you check at the start. No, I'm at the end. So when breaking down from the snap roll, you're only using 20% throttle, so a bit more P-term and quite more master multiplier. I would say like 0.2 more. Yeah, it's quite conservative for 5-inch, unless you got drilling problems from your high D gains. looks reasonable. I prefer to leave my sliders closer to the center and work with the master multiplier than having all the sliders up. Okay. Did it load the other log? Nah, it's still waiting. Here it comes. $2.14 in the log. So we can probably show a desync event. Let's fast forward. Hui! I'm not sure if you crashed into something. Okay. Smooth flight. Pulling out. And D-term goes crazy. Let's look at the motors here. Okay, it starts with motor 2. Motor 2 was probably desyncing. No, it should spike up when it's desyncing. And it can't get... Oh, that takes forever. Did it get back to sync? That is long. Yeah, I think here we're good again. Pooh, 1 second. You were obviously high in the air when this happened. Yeah, it's alternating between... Nope. Oh, gyro. Yeah, ignore the blue line in here. Wait, let me just get rid of the gyro line. Okay. Okay, starts with motor 2, front right is desyncing. It's out. It's revving up again. Probably putting too much power in. Desyncing again. The single spikes, you can ignore them. It's just either errors in D-shot communication, or it's read errors from the ESC. But it still puts the value out. I want to see the video. No, it won't give it to me. Here we are. Out of the blue. Okay. Slow loop. Dip in. Okay. You were sure lucky on that one. Stop. How do I get this back? Here we are. Okay. I would you set demarc compensation to high, and check the motor wires. Check the solder joints, because sometimes due to vibration, when you get a cold solder joint, due to vibration it separates, and not only you can't put power to one phase, you also can't detect the zero crossing properly on that phase when the connection is flaky. Could be a mechanical error, could be a motor going bad. Depends on how the motors physically look. If they are worn out as hell and you smoke the enamel of the windings already a bit, you can smell this. Might be easiest to just get a new motor, but it happens so out of the blue. How much T-turn do you run on this? Standard settings, bit more feed forward, bit more P. RPM filtering active. I strongly advise against running the bike watts, but this is not the problem of this rig. So yeah, higher motor timing. Try the next step, and to bring this out, normally you would do snap moves, snap flips, snap rolls. Fly high up so you're sure it might recover. And try with higher motor timing. Let's check your one dynamic notch. Just to. Oh, come on, why is this so slow? Martin. What prop are you swinging? And what's the kV of the motor and what battery voltage you're running on it? There's no. Yeah, there's obviously because he's logging the ERPM, so there's no gyro scaled in it. Look at the raw gyro traces. We can just peek into D term and see what makes it into D term. Okay, wait. Brendan, I'll try to open your other log. Yeah, we know this is working. Mm. Oh, 2, 3. Um, 1507. Martin, can you put a picture from the motor? I'm not sure if it's the one with the tight air gap or is it? No, it's the 1406. It's like a 1406 from T motor, and it's really really notchy. It's like tuck 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 tuck. And I usually on a notchier motor, if I have troubles, I need to go to higher timing. But that's the 1408. And I don't have a 1507 from them. No, the KV on 4S is perfect. You could go a little higher if you want a lot of speed. But Martin, have you counted the magnets of this motor? I suspect it's a 12 pole motor and not a 14 pole motor. So we have to change this in the motor settings from Betaflight configurator down to 14 if it sits at down to 12 if it sits on 14, because usually on a 15 starter there's not enough place for 14 poles or for 12 windings. It's just 9 windings. So count your magnets on the bell. Just mark the first one with a Sharpie if you have a problem, and run through it and count them. Because from the D term trace, you can clearly see the first motor harmonic, and RPM filters should crush them down to it's a fast log, down to 150 in the standard settings. Let's see. In the motor settings, no, doesn't tell. Yeah, Martin, make sure you got the pole count right. It looks suspiciously, and you see, you have really the strongest filter you can apply at, on D term, and it still can't get rid of the first harmonic. So either your RPM filtering is set wrong, or you just didn't set the motor poles correctly. The motor has 14 poles, or you set it to 14 poles? Because with the standard settings, there shouldn't be that much of the motor noise in the D visible, and this is with standard gains. Often I see get this one. Oh, come on. Oh, I got so much noise. No, you turned the gains up. This might be a resonance at about 170, but it's pretty low for a frame that size. Okay. Entertaining. Wait, this is Brandon's new log. Morse Russell. Ah, this is a nice trace. Let's see the noise in this week. Brandon, this is the one you sent me, the Sky Star F7 HD. I didn't know that the T-motor made a 14 pole that size. It's nice, should run really smooth. Yeah, sorry, everything takes forever. But I can't turn off OBS for obvious reason. I should get a second computer. I should use one for streaming. Oh, damn it. Did it turn the gains up, or is this... Okay. Still the frame. Yeah, the frame is pretty soft. It really hurts because it's a super light frame, but that resonance over here and that mushy resonance over here. I think this is resonance 2, but you can't be sure. This is roll. Let's see if it's better on pitch. No, wait. I wait for the pitch graphs. I assume those, let's see. No. Uh, wait, did you notch this out manually? The 250 on this one? No. Brandon, why are you using only one notch, one dynamic notch when you have two resonance peaks? Oh, on this log I would use three notches, three dynamic notches to make sure to catch the one at 160. You got this at 260, and you have here another one at 440. And let's hope the axes match up, but probably they won't. You don't have to explain. You try it for curiosity. Do it for science. you don't you don't have to reason. What would be fun if you find out something? Let us all know. No, they don't line up. The one lines up. Now two line up. Three dynamic notches should get most of it. Let's see if anything makes it through. Oh, come on. It's incredibly slow. Yeah, nice. I gotta get this motors, but currently, um, ordered custom motors from T-Motor for 3.5 inch. Yeah, based on the Pacer 1604, which took me by surprise because I had them lying in my closet for half a year because the tubular build needs 12 millimeter mounting, and on my new rig on the Squirrel I can fit like 9 millimeter mounting. The distance between the screws. And I approached T-Motor for a proper motor for 3.5 inch, and they say, yeah, we have this and this, and I got this spiel already from RC and Power, and they only wanted me to try what they already producing, so that's why I run this. What's the dentist called? FPV cyclist, the dentist. Motors. They are unbranded because they are prototypes from RC and Power, and the 1404s. Those are just too heavy. And the 1404, if you ask some torque from them, they will desync. So it's, and T-Motor did the same with me and say, hey, I got this spiel from RC Power, but I think I have those motors lying. Please try them. And I put them on, and those are the best freaking motors I've ever had on 3.5 inch, and they're incredibly light. They're like 12 grams, produce a lot of torque down low, so you can run pretty low D gains. And I only run like 20% thrust linear on it. Usually on motors that small, around 40. They're just a bit too slow. They are nominally there are 3650 kV, I think. And I have a special batch made for me with 4000 kV. They are in production. I hope I get them by the end of the month. Mm, no, with Betaflight, 4.3 or 4.4 onwards, you can have 80% CPU utilization and you're safe. Because the scheduler is much more precise now. Okay, I will. Why? I don't want to shorten the names. Okay, I will do one more log from Ciao for comedy value. Ciao value logs. Blue Jay timing high. 7. Did it desync? Yeah. Brandon, this is still your log. And RPM filtering works beautifully, but yeah, this should be done by the gyro low passes. I wouldn't take too much care, but everything below the second low pass, I would try to set enough dynamic notches to catch this. So it's you need 2 more dynamic notches. So this here and this here. Nope, not the one I wanted. Whip out. Yeah, one more lock, one more cigarette. Joe, which frame is it? Can you post a picture? I'm always curious what people come up with. Most of the time slightly disappointed because it's another school bus frame. And you know, I designed different. I went to a concrete Brando, and it was carnage. Me and my son destroyed 4 rigs. I had one of my prototypes. Here is I was watching for this. I was searching for this for an hour. So I broke an arm over here. but it's just fair because the props were bent beyond recognition. This is the broken off arm and wait, where's the bend in the motor? Here. When you look at it, it's not round anymore. It's so badly dented. So I think it's okay. It broke off. Yeah, but no school bus frame for me. This is where the battery goes right in the prop line. I had to stiffen it up in the back a bit because the tail was resonating at a 120 hertz, so I had to do it higher. But it was full power into concrete, and the O3 is survived it. Basically, I just lost the motor and the cap at the back went tumbling down, exploded. Lots of throttle pumping. Oh. Is it desyncing at the end? No, it looks fine. You got a little overshoot. Where's feed forward here? No, that's nice. You're on the edge with your feet forward. Might put it one tick down or half a tick down. So you it's not the end of the world. But when you see that your PID term starts fighting feet forward, then you have too much feet forward. The overshoot here is from I-term winding up. So you might suppress I-term a bit more on fast stick inputs. But it's already starting to wind up here. Did you change? I-term relax quite a bit. Roll pitch set cut. No. That's a light frame with quite a steep prop, I would suggest. But with because the gains aren't that. Oh, you. Edog, I don't need to remember those. I just look at those for aesthetic reasons. And basically, I want that blue line to follow that green line smoothly, which this one is not. Yeah, I should run a bit more P. Let's see if the filtering is sufficient. Ah, here it is. sweet. I like the look of it. Uh, oh, it's a two-piece arm design. That's very interesting. But is the in the corners, is the motor holding together the arms, or is there a pressure plate beneath adopted? Because the TPU is too little to hold the arms together, so they will swing independently from each other when the motor is moving around this axis. I would. How thick are the arms? If the arms, it's supposed to be a light build, so I guess it's like five 5 mil arms. At dig this design, it's really nice. You get a better view on it. Um, yeah, it got a little curve in to interlock them, but I doubt it's enough to have those two arms um, be reliably connected together and not share side by side. The only one harmonic at 250 hertz, it's fine. You're trying to get rid of this with the low pass. Seems. Let's see how much makes it through. Sorry for the slow computer. Yeah. This low pass is not cleaning up the noise over here. It's the RPM filters are working, so you can go up to 800 with the gyro low pass just to get electrical noise, or should you have it. The I'm just looking at roll. Sorry for being lazy. Yeah, Brandon. When the I can't pull it up now, but when the motor the first motor harmonic mainly when it's so wide, that doesn't mean there is a broad noise spectrum at any given point of time. It just means that at its throttle, you see down here, Jiao is pumping a lot, and when you pump, you have a high throttle, but the motors are still ramping up. So this graph, yeah, I need to put it on. Yeah, there's still a lot going into the term. Come on. That means that at 60% throttle, one motor is turning at 320 hertz, and at another time it's turning at 500 hertz. This is the scale, the y-axis is the throttle position. It's not the motor speed. Usually at a given throttle position, all motors turn more or less at the same RPM. But when you're pumping a lot, uh, on the way up, the motors are slower than they usually would be at that throttle point. And when you pull the throttle, the motors are slower. The motors still spin faster than they usually would do. That's why those white things come from. If you reduce it to a piece where it's not pumping that much, but we would need a slow ramp. No, let's have the endpoint here. It needs to recalculate the FFTs when you set an endpoint, and that's why we're waiting now again. I wanted to set the endpoint here. Yeah, the RPM filter is not bound to the throttle value. It's bound to the ERPM, to the real ERPM that is reported back by the ESC. Why we specifically have this 250 hertz very often. Let's see if I got an arm. Because the arm lengths are pretty similar. Wait, where do I have the cable? Prototype arm. Let's see if you can hear this. Yeah, it's too stiff, but the length of the arms, the resonance frequency of one part in the system is defined by the length and the thickness and wideness, and if you cut it, you got the surface area. The higher the surface is, the higher the frequency gets. And all our belts have similar arm lengths and similar material thickness. So often, if you would take the same arm and cut it from 6 mil, you will get a 20% higher resonance frequency than you have at 5 mil. We also have a resonance over both arms, but that's usually dampened by the top and bottom plates that are way stiffer because they are separated by the arm thickness. So you have 2 mm plates with 6 mm in between, will be much stiffer than like 5 mm in the middle going through. So basically the main resonance is just the arm length. No, I think there should be enough. Or are you just... Wait, let's set an out point here. No, before the second pump. Out point. So that should recalculate way faster now. Yeah, we don't have any full throttling. Yeah. Chow, is the rig symmetrical? Is it the same width? Honestly, I would try a pressure plate on top of that link. Simple carbon plate on top of this, just 2 millimeters should be enough to keep this in place, and uh, overcut it. The in this seam, make it so that the seam is less than 0 millimeters, so that you have to press both arms together to get the screw into the motor. So you have a bit of bending force on the screws that pushes the plates together, and put a pressure plate on it. I use this on my destroyed. Yeah, was the last flying bird, but use a pressure plate like this on top. I need to have it because it's all just TPU, but this keeps it together. This puts pressure on the TPU to keep this mount in, and I think a 2 mil plate, or whatever the main body plate is made of, because you don't need, you not even paying for extra carbon. You have enough place over here. When you take this carbon plate, they will calculate it on a rectangle like this. So if you put in a pressure plate in here, you don't have to pay extra for it. It's zero money. It's one step when building it, but if it keeps the arm part, the split arms interlocked, it would make the whole thing way stiffer. And I'm not sure if this how deep this arm goes in, because the problem is, the arm needs some surface area here where it's sandwiched between the bottom plate and the pressure plate on top. But otherwise, I dig the design. Looks really nice. The locks aren't there yet, but I think in another two revisions, it will be a nice addition to the five available more exotic 5-inch frames. Ciao. You won't hear this often from me. Um, but this might be a case where a single bike rod or PT2, or a PT2, static PT2 at 130, and a second and a PT1 at 230 might serve you better in keeping the noise out of your D-term. So you could run more with D-term on it. How's the cap mounted? How much capacitance do you have on the ESCs? Oh, okay. Which one is the original lock disaster? Open is Razer Acro, Blue Jay, High Timing, and which one do I have open right now? Because it takes forever. the 5 megabyte one. So this is the small one. Let's see the original disaster for a good laugh at the end. No, I said PT2. No, it might even ask for a bike rod, but I would put a bigger capacitor on it before to make sure it's not an electrical problem. We try to kill with unnecessary delay. Did it work better with 1000 microfarad? Let's threaten him again. It is still here. I assume it's my network that got the issues, not yours. Um, Joe, did it work better with the 1000 microfarad, or did it change nothing at all? And now to the fun. Log. I have to at least react to this. Yeah, that's the arms. He clearly needs to make the arms a bit wider at the base. Maybe even is this stack mounting already? This 20 and 30 stack mounting and 25 in this direction. So he can't get in here with the arms. This is oh, yeah. Which beta flat version are you on? Four. Still a lot of noise coming into. Oh, this is just P term. Oh, this is just because there will be a lot going on. This rotates like this. Oh, this explains the swelling. Yeah. When this rotates on this axis, it will shift the short arm up and down, and the first harmonic, what you see here. Wait. Come on. So the 250 that you get here, I think I measured it at 250 hertz. Yeah, about 250. This is the arm vibrating with the motor. But what happens is that the vibration is migrated here and here, and now this corner is vibrating with 250, and this is vibrating with 250, and they're not exactly the same. So the difference between those two generates the swelling here. If you hold it in, you see this swelling, and this can give really nasty artifacts because it's pretty erratic and will shift in frequency by almost a harmonic. So it's like plus minus 50% from peak to peak. Mark. So you have one swell here to the next is 30 hertz. Then you got a little faster 50 hertz. The next one occurs 44. Then it's a long one that starts at 30, tapers down. There's probably a throttle change, a throttle cut. And here it starts again. So this is the problematic part with a strut structure like this, is that you start to see multiple resonances interacting, and the interacting part is generates movement on a frequency that you can't control anymore because it's well in control range. So you would react to something that is just a swing caused by by 2 or 4 faster swings, and you can ignore every single one of those up downs. You can easily ignore and filter out, but you can't ignore the hull of those. But he should try just with a pressure plate. Yeah, Ciao, where do you get the cap from? Capacitors vary very enormously in internal resistance and in real capacitance. So I actually still have to run those. I bought like 20 different capacitors for 3.5 and 5-inch rigs. Panasonic FM are usually solid, but it could be burned out. But if it's fresh from the package, it should just work. Yeah, it's hard because no one has the tools around to measure capacitor. Okay. Oh, it's already 1/2 past. I will call it a day. Thank you all for coming. Ciao. I will stay in contact on Discord. Bye, everyone. Thank you.